We live in a data-rich world. At any second, I can check the stock prices in New York and even the traffic in London. Yet, we are blind to the invisible risk in our room now. A standard sensor gives me data, 30 degrees, but it lacks the context to tell me if I'm actually safe. So, we built Lumina to close the gap. It is an ambient intelligence system designed to bridge the gap between complex sensors and human understanding. It translates raw telemetry into actionable safety insights. The system begins at the edge. Using the MYOSA sensors, which provides a lot of autonomy and flexibility, the ESP32 executes a sensor fusion algorithm, sampling inertial, thermal, and optical data. This telemetry is packetized into string payloads and transmitted via HTTP post to a local Apache server. Here lies the core mechanism, a custom PHP middleware layer. Instead of simply logging raw integers to a SQL database, the middleware serializes these vector arrays into natural language context strings, effectively translating binary machine code into human-readable text. This structured context is injected into the Nvidia Nemotron 30B large language model via an API call. The LLM analyzes the change between previous and current states to infer user safety. Watch what happens when we block the light sensor during the day. A standard device will just report a low reading and do nothing, but Lumina understands context. It cross-references the sudden darkness with current time, 11 a.m. It realizes it should be bright right now and advises me to open the blinds. Now, testing the safety protocol. We simulate a sudden fall event. The system first registers a high G impact spike from the accelerometer, but it doesn't alert yet. It checks the tilt angle. Since the sensor remains horizontal and motionless after the hit, Lumina confirms it's a critical fall and triggers the emergency notification. We also prioritize data sovereignty. Unlike cloud-locked commercial devices, Lumina ensures users retain full ownership of their biometric history via local CSV exports. But this is just version 1. We are actively seeking contributors to help us integrate I2S text-to-speech for the visually impaired and replace our threshold logic with tiny ML models via Edge Impulse for superior accuracy. We also plan to implement MQTT bridging, allowing Lumina to directly control smart home devices and thermostats based on its environmental analysis. Lumina proves that by bridging embedded hardware with generative AI, we can turn silent environments into active, intelligent guardians.